This video is talking about the fundamental theorem of algebra. Again, this goes along with the study of polynomial functions and synthetic division. The fundamental theorem of algebra states every function defined by a polynomial of degree 1 or more has at least one complex zero. Now you remember we talked about complex numbers earlier. All numbers are complex. They consist of either a real part and an imaginary part. However, a lot of numbers don't. The imaginary part doesn't show up. So this follows suit definitely with the fundamental theorem of algebra. The number of zeros theorem, a function defined by a polynomial of degree n, or degree n means the highest power term in your polynomial, has at most n distinct zeros. Find a polynomial function of degree 3. So that means my highest power should be the third power, with real coefficients that satisfies the given conditions. The zeros have got to be 2, -3, and 5. And also, we know the f of 3 has got to equal to 6. So it's possible that we could have some multiplied coefficient out front that would affect the fact of f of 3 equaling 6. So we got to kind of use a variable to kind of help us with that. So f of x, we know the basic skeleton of that function. It's going to be some constant out front. We don't know. It could be 1. We don't know. Times the factor. Since we have a 0 of 2, then you know you had a factor of x minus 2. Since you have a 0 of -3, you know you had a factor of x plus 3. And the fact that you had a 0 of 5 lets you know you have a factor of x minus 5. So let's see what we've got so far. We can find we can multiply all this out together. If I multiply the first two together, that would be x squared plus 3x minus 2x, so plus x, then minus 6 times the x minus 5. And then we can multiply those also. So x squared times x would be x cubed. X squared times minus 5 is minus 5x squared. X times x is x squared. X times minus 5 is negative 5x. Now the negative 6 times x minus 5 would be minus 6x, and then plus 30. So that gives me a times x cubed minus 4x squared minus 11x plus 30 for my supposed function. F of x could be some constant a, we don't know, times the polynomial x cubed minus 4x squared minus 11x plus 30. So the last tidbit of information we're going to use is this, that f of 3 is equal to 6. In other words, if I plug in 3 in for x, I should get 6 as my output. So 6 is equal to a times, if we plug in 3 for x, that would be 3 cubed, 27, minus 4 times 3 squared is 9, so minus 36. Okay, minus 11 times 3, so minus 33, plus 30. So let's see what we get here. Over here to the side here. So 6 is equal to a times, let's see what we would get when we do all the number crunching. 27 minus 36 minus 33 plus 30. I got negative 12. I'm going to double check my arithmetic there. 27 minus 36 minus 33 plus 30. Got negative 12. So to solve for a, we would divide by negative 12. So a is equal to negative 1/2. So our function f of x that makes this all true, f of x would be negative 1/2 times x cubed minus 4x squared minus 11x plus 30. Now if you want to go ahead and multiply all that out and distribute the negative 1/2, you can do that. I'm just going to leave my answer like so. Okay, find a polynomial function of degree 3 with real coefficients that satisfies the given condition. So we have zeros of 2, a 0 of 4 having multiplicity 2, and the fact that f of 1 is equal to negative 18. So the basic skeletal structure here of my function is a 0 of 2, so that's going to, well, first of all, we'll have maybe some coefficient out front we don't know. We're going to say a. A 0 of 2, that's to mean x minus 2 will be a factor. A 0 of 4 having multiplicity of 2. So what that means is you're going to have x minus 4, but it's going to be squared because you had a multiplicity of 2. So, of course, that should be all I have there. Now, f of 1 equals negative 18. I'll come back and try to find the a part at the end. But let's multiply out and see what we've got so far. X minus 2. If I square out x minus 4 squared, that's x squared minus 8x plus 16. If you FOIL or use the squaring of the binomial method, then we'll multiply x minus 2 times everything. So that's going to be x cubed minus 8x squared plus 16x. Then we'll multiply the negative 2 throughout. So minus 2x squared plus 16x minus 32. So the basic structure of my function that I've got is a times x cubed minus 10x squared plus 32x minus 32. Now the fact that they told us that f of 1 equals negative 18. So that means if I plug a 1 in for all those x's, that the function should equal negative 18. So let's see what we get here. Negative 18 equals a times, if I plug in a 1 for all that, 1 cubed is 1, minus 10, plus 32, minus 32. So come up here to the side. Let's see what we would have here. Negative 18 equals a times 1 minus 10 plus 32 minus 32. I got negative 9. So if you solve for a, if you divide by negative 9, a equals 2. So f of x would equal 2 times x cubed minus 10x squared plus 32x minus 32. You could distribute that too if you would like. All right. Conjugate zeros theorem. If f of x defines a polynomial function having only real coefficients, and if z is equal to a plus bi is a 0 of f of x, where a and b are real numbers, then z complement is the conjugate, or the conjugate of z is also a 0. A complex number that involves an imaginary portion can never be a 0 of a polynomial by itself. You have to have both the complex number and its conjugate. So if you have a plus bi, you also have to have a minus bi. They both have to be zeros of the polynomial. They always occur in conjugate pairs. You can never have one and not the other. So let's look at a problem. Given 1 0 of the function, find all of the other zeros. So 2 minus I is a 0 of the function x cubed minus 7x squared plus 17x minus 15. So the fact that 2 minus I is a 0 is a great hint that the other factor is 2 plus I. So you're going to, if you have 1, you have to have its conjugate as well. So 2 plus I will be the other, but you're going to have 3 roots, so we'd have to find the last one as we do this. So let's go through some synthetic division here. let's see, if I were to divide 2 minus I out of my polynomial, 1x cubed, negative 7x squared, 17x, and negative 15. Okay? This is going to be a little bit more difficult to kind of do this synthetic division, but we can do this. So if I bring the 1 down, 1 times 2 minus I would be 2 minus I. So if I combine those, that's going to be negative 5 minus I. If I multiply this together, let's see here. Let's go to the side. 2 minus I times negative 5 minus I. If we multiply those together, we get negative 10 minus 2I plus 5I plus I squared. So for what we know about complex numbers, that's negative 10 plus 3I minus 1. So that would be negative 11 plus 3I. Okay, combining those, I would get 6 plus 3I. Okay. Now, 6 plus 3I times 2 minus I. Let's see what happens there. So I like doing this little side work here when I'm multiplying complex numbers together. It kind of helps me keep everything organized. So, let's see here. I got 2 minus I times 6 plus 3I. So if I multiply that gives me 12 plus 6I minus 6I minus 3I squared. So those drop out with subtraction. 12, negative 3I squared will be plus 3, which is 15. So 15, which means I have a 0 for sure. Okay, so that worked out good. We were told that 2 minus I was a 0. So now my polynomial, or my equation, has been diminished. So now I don't have to divide into the other. Again, I can divide into this more diminished equation. So I'm going to do 2 plus I. Let me write this out over here to the side. 2 plus I. We're going to divide that into 1, negative 5 minus I, and 6 plus 3I. Okay, so let me erase this information right here so we can use the space to work our stuff out. Okay, so I'm going to bring down the first term as is. 1 times 2 plus I is 2 plus I. Notice what happens when I combine that. I just get negative 3. The i's drop out. And then if I multiply negative 3 times 2 plus I get negative 6 minus 3I, which gives me 0. So 2 plus I is definitely a factor as well, which leaves me now a diminished equation down into, it went from x cubed to x squared, now it's x and the constant. So this is x minus 3. If I set that equal to 0, then my last root is going to be x equal to 3. So given 1 0, we found all the zeros of this function. The zeros are x equal to 2 minus I, 2 plus I, and positive 3. Find a polynomial function of least degree having only real coefficients and zeros as given. So the fact that we know that x minus 1 is a 0 and 4 minus 2i, just the fact that we have one complex 0 that has an imaginary part, we have to include the conjugate as well. So 4 plus 2i will also have to be a 0 of the function. So the skeletal system here of this function, the least degree is going to have to be at least degree 3. For negative 1 to be a 0, we have to have x plus 1 as a factor. All right, and then for 4 minus 2i to be a factor, you had to have x minus 4 minus 2i as a factor. And for the 4 plus 2i, we would have to have x minus 4 plus 2i as a factor as well. So let's see what we got here. A little algebra, the minus sign needs to be distributed, so I have x minus 4 plus 2i, and then x minus 4 minus 2i. So we can multiply stuff out. I think I might have better luck by multiplying the two complex factors together first. So x plus 1 times. Okay, if I multiply these two polynomials, I get x times x, which is x squared. X times minus 4 is minus 4x. X times negative 2i is negative 2xi. Okay, so now I'm going to multiply the negative 4 times everything. So negative 4x. Negative 4 times negative 4 is plus 16. Negative 4 times negative 2i is plus 8i. And then 2i times everything, so plus 2xi minus 8i and minus 4i squared, which we know is plus 4. Okay, so that leaves x plus 1. So I have an x squared. Let's see what happens here. The negative 2xi and the plus 2xi cancels out. 8i minus 8i cancels out. So it looks like we have minus 8x. And then 16 plus 4 will be plus 20. Notice all the i's are out of the equation now. So all I have to do is multiply x plus 1 times this other polynomial. So x times x squared is x cubed. X times minus 8x is minus 8x squared. X times 20 is 20x. Then multiply the 1 times everything. So plus x squared minus 8x plus 20. So my whole answer, let's combine all the like terms. F of x would actually equal x cubed minus 7x squared plus 12x and plus 20. So there is my polynomial of least degree.